Well, hello everyone. Welcome to We Need Our Space Live. This is indeed live. July 23rd, almost my birthday. And today we're going to be talking about comets and the comet that you can find tonight in your nighttime sky. Just an hour after this show is over with, I'm going to turn down the music just a bit here. There we go. Okay, well, come on now. All right, that's fine. That's fine. All right. Okay. Well, yeah, this show is going to be all about comets. We are live right now. So I'm going to get away from the comment section in Facebook, Twitch, and YouTube and get right into this show right now. So yeah, we're going to be covering a lot here today. Some of the more notable comets that have visited us here on Earth, as well as the comet that you can see tonight in your nighttime sky about an hour after the sun sets. So let's get going here. All right. Well, tonight... There we go. Well, tonight, just after sunset. Actually, hang on. I need to minimize myself, don't I? Always got to remember to do that. All right. There we go. Now we can rock and roll. And here we go. So that is a picture of Comet Neowize. Get this closer. Tonight, just after sunset, you can find this comet in our nighttime sky. Now, you may have heard of this comet. Hang on one second. Of course, you do know this is live because constantly adjusting stuff. I only have two monitors here. All these programs opened up. Got to monitor my feed, make sure that is going. All right, now we're gonna go. Okay, so yeah, this is called C2020 F3 NEOWISE. Now, NEOWISE is the nickname of this comet. The official name is C2020 F3, and it was discovered using the space telescope named Neowise, hence the name. Now you know where it comes from. And here is that little space telescope right there. Well, it was back in late March that astronomers using a space telescope mission called Neowise discovered a comet heading around the sun about 160 million miles away from Earth. Now, it's about a 3-mile wide chunk of ice and dust, and it's on about a 6,800 year loop around our solar system. So no, you're not going to see this for another 6,800 years, probably. Now, tonight, July 23rd, it will reach its closest approach to Earth. So here's what amateur astronomers have suggested in order for you to see this comet tonight. Now, first of all, this comet, like all comets, consists of a dense nucleus made of ice, dust, and ionized gas that forms a brilliant double tail as they blow off the comet. So this tail is huge. It covers as much sky as if you were to place 12 full moons side by side. Now, the best time to see this comet tonight will be about an hour after sunset. Here in Baton Rouge, that will be at 8:05 p.m. Now, that will be that won't be when the show ends. Okay, so you can see if we can find location. Okay, so here we are. So it is the 23rd. So there it is. So there you have the Big Dipper, and then there you will have the comet right there on 23rd. So pretty close to the horizon. So you have time to hunt this down with binoculars to help you out. Binoculars will definitely help you see it. Now, depending on where you live, the best time I found was around 9 to 10 o'clock at night. Now, the comet will be visible for about an hour or so before it drops below the horizon. It'll have to be a very dark enough outside in order for you to see this, for you to pick out the Big Dipper. So if you can, the point whenever you can see the Big Dipper, you know you've got a good chance here. So find the Big Dipper, the cup of the Big Dipper right there in its handle, and then towards the horizon, you will see this fuzzy looking star. So it'll be around the bottom of the cup of the Big Dipper, and you might need some binoculars to see it, since it will be dimmer at around this time. Now, to help you find this comet, there are some apps that you can get for your phone that could help you out. There is Sky Safari for both iOS and Android, but that'll run you about 20 bucks. And there is a free app called Sky Portal, and so you can check that one out. That might help you out. Sky Portal and Sky Safari. Those are two apps that might help you find this comet and where it's at. So these are a couple of the photos I took last night right outside my house. This is right outside my house, Denham Springs, with all the street lights. In fact, you have this glow down here that is from one of the street lights right by my neighbor's house, and you have the trees here that you can see are being lit up by the street light. And right below the end of this picture is the roof, which I intentionally cut off. Now, I don't know what that is up there. I don't know if that's a plane or if that is a shooting star, but that right there is going to be Comet Neowize right there. Now, I thought that this was kind of serendipitous, that little glow there. I thought it made the picture look very pretty. Well, kind of serendipitous, but this was with a 50mm Sigma lens. I have a Nikon D810 DSLR camera. Now I believe this was a 6-second long exposure, so you can see all these stars here. Now this is way more stars than you would see with your naked eye. Now, basically, what I'm trying to say is that you can achieve good results of viewing this if you have binoculars or a camera that can do long exposure, even if you're in an area that has a lot of light. Because in my area, there's a lot of light. There is a baseball field behind me. There's a football field on the other side, and there are street lights everywhere. But despite all that, I was able to capture this picture here. So a 6-second long exposure with just a standard 50mm lens. Now, the other photo I took was when I backed my camera away from the street light and kind of had the roof block that light. So a different little color scheme to go in there, but you can still see the lights illuminating the trees at the bottom of the picture, but you can clearly see, again, the comet right there. So what gear do you need to see this comet tonight? Before I talk about gear, let's visit this bad boy up close. Here we are just above Earth, and I'm going to type in the name of this comet. There it is, Neowize. Let's see what a comet looks like up close. Just a big old ball of rock. Push that away a little bit. Okay, there we go. So let's talk about this for a second. Well, you can see it whether you live in a city or not. If you do live in a city, you'll have a much harder time seeing it. Now, binoculars will help you see it better, in much better detail, but if you don't have a pair of binoculars, you can always go far out into the country for a better shot at seeing it. Now, don't expect to see it like you've been seeing in the pictures, like the pictures I'm showing you here. Those are long exposure photos, but that's able to catch the comet and the stars in the nighttime sky in much finer detail than you can see with your own naked eye. Now, you've got, oops, there we go. What's that? There we go. Cool. So if you've got a DSLR camera, you can dial back the exposure just a bit to leave the lens open for a long period of time. Now, why do you want to see this? Well, 10 p.m. might be a little bit late for some of you. I know that some of you have work in the morning, but keep this in mind. There is a rock as wide as Manhattan, and it is shooting through our solar system at 150,000 miles per hour. And it will not be back to see us for about 6,800 years. So comets that you can see with your naked eye or binoculars is a rare occurrence. So when you've got the opportunity, you should probably take it. Now, of course, when it comes to comets, the most famous would be Halley's Comet. Oops. Wrong program. There we go. Halley's Comet. So let's visit Halley's Comet and see exactly where it is at now, because the last time we saw Halley's Comet, it was several years ago, back when I was just 10 years old. So where is Halley's Comet now, and what has it been up to? Well, there is Halley's Comet right there. Right now, Halley's Comet is right outside of our own... Back away a little bit here. It's going to be right outside the orbit of Neptune, I believe. I'm currently backing away from it. Eventually, we're going to start leaving the orbits of our planets to see the orbit of Halley's Comet in relation to the other orbits. So here we are. Okay, so here is our solar system. And you can see how the orbit of Halley's Comet is very oblong. Looks way different than the other planets. So here is, this is the orbit of Uranus, and that is the orbit of Neptune. And again, Halley's is right there. So it's heading back our way. Last time it visited us as it was in 1986. So right now it lies outside the orbit of Neptune. Now, not only is it the most famous comet, but it's been featured in several movies as well. You may remember it in such films as The Adventures of Mark Twain and Night of the Comet. Now, both of these films are kind of terrifying, especially if you're a kid. Now, I was 10 when Night of the Comet came out. I think it came out in '84. Yeah. Now, if you've never seen Night of the Comet and you like horror films like me, it's worth checking out. Basically, what happens is these people have a comet watching party, just like the entire Earth has this party to watch Halley's Comet zoom overhead. Well, what they didn't know was that this comet was going to wipe them all out, right? So if they were not in some type of metal enclosure, like a shed, or like one of the characters was in this projection booth at a movie theater, they were safe. They were okay. But the people that were outside watching Halley's Comet ended up as red dust. But not all of them. Some of them turned into mutants or something. I don't know. But yeah, that was what that movie was about. Halley's Comet zoomed past Earth and did some type of shenanigans. And then you've got The Adventures of Mark Twain. And if you haven't seen The Adventures of Mark Twain, boy, is that a weird movie. But these two kids, I believe it's, was it Huck Finn and Tom Sawyer, go and meet up with. Anyways, aside from that, okay. Well, it was the British astronomer Edmund Halley who was the first to realize that comets approaching Earth in 1531, 1607, 1682 were all the same comet. Now, a lot of people say Halley's Comet. It's actually Halley. It rhymes with valley. Well, he predicted that this comet would be back in 1758, and he was right. Now, the last time it was with us was in 1986. And I remember this because I was 10 years old at the time. Kind of revealing my age a little bit right there. So the next time it will be back will be in 2061. Let's take a look at Halley's Comet again. Zoom back in here. Don't want that. Zoom past it. I'm gonna do this. There we go. Take those orbit lines out. There we go. Hey. And for fun, now we're gonna land on another comet. Anyways, this is Halley. So it will be many decades before we can see Halley's Comet again, but each year we can see remnants of it in the form of meteors and meteor showers. Now, the Orionid meteor shower is spawned by fragments left behind by Comet Halley. This occurs each year around October. Now, Halley also produced a shower in May called the Eta Aquarids meteor shower. Now, Halley's Comet is about 5 miles wide, and when it comes back in 2061, it will be on the same side as Earth. So it will appear will be on the same side as Earth as the Sun. So it will appear to be much brighter than it was in 1986. So, you know, mark your calendars for that. And if you're my age, you might have a good chance if you find a vampire to bite you, and then you can last until 2061 to see Halley's Comet again. Fingers crossed. Well, another notable comet we had was Shoemaker Levy 9. Now, you might have heard of Shoemaker Levy 9 because it is the comet that crashed into Jupiter and left all these bruises along the lower end of Jupiter. Now, I can't show you this comet because it has busted up into several fragments and now it has been destroyed by Jupiter. So what happened was, as it approached Jupiter, it got sucked in by Jupiter's gravity, and the stress of this gravitational pull broke the comet into about 21 pieces. Now, this was first observed as it was whipping around Jupiter around 1992, and then in 1994, it pelted the gas giant in a spectacular fashion. Now, you might be asking yourself, why did it take so long for this to happen? Well, actually, we think it went into orbit around about 10 years prior to that. So we do know that it was orbiting for about 2 years and finally crashed into its surface. Thank you for asking. But it is thought to have been orbiting Jupiter for about a decade before finally crashing into it. Now, one fragment yielded an explosion and a fireball equivalent to about 6 million megatons of TNT. And the plume of this explosion reached about 13,700 miles above the cloud tops of Jupiter. Now, this is important. Shoemaker Levy 9 was important because it is very rare for us to see a comet captured by a planet, in orbit around the planet, and then crash into the planet. And when it did this, it left all these dark bruises on Jupiter. And those bruises were eventually sort of swept away. That's a little example of the crashing into the surface there. All these bruises were sort of swept away. All these little cloud bands and colorful cloud bands you see of Jupiter, those are storms raging across the surface. Eventually, those storms sort of washed those bruises away. Now, before we continue on, let us answer some questions about comets that you've probably wondered about. Well, first off, I'm going to show you... Let's go back home for a second because I want to show you something kind of cool. Okay. Bring up the orbits of the planets here. Let's see here. A little bit faster here and speed things up here. Yeah, we're seeing Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then you have the dwarf planets. The furthest one out here will be Eris. Well, there is our solar system. Now, the reason why I am showing you this is because I'm going to show you some orbit lines of these comets. There are many comets. Now, you might think that there's maybe 1 or 2 in a generation, but no, not the case. So comets orbit the sun just like planets, just like asteroids do. However, a comet usually has a very elongated orbit. As the comets get closer to the sun, what happens is some of the ice starts to melt and boil off. Now, along with the particles of the dust that's kind of trapped in there as well. So these particles and these gases make a cloud around the nucleus called a coma. Now, the coma is lit by the sun. The sunlight also pushes this material into this brightly lit tail. So there are about 7,000 comets in orbit in our solar system, and we're still discovering some more. So let me turn on bring this over here, the orbit lines of the comets, and there you see this, and I will have to zoom out even more to see just how elongated these orbits are and how far out some of these comets go. It's crazy. This is why they take so long. Like some of these, have crazy orbit lines. So those are just a few of the comets that are orbiting our solar system. So at this point, there's around 6,870 known comets. That was about a year ago, so I'm sure by now they've found far more than that. So that's why I said around 7,000. So yeah, a comet is a huge snowball. Let's take a look at this. It's a huge snowball, but what is at the heart of a comet? Well, it's easy. It's mostly marshmallows and peanuts and chewy nougat and chewy caramel. And that's not really the case. No. We now have a better idea about what is at the heart of a comet because we sent off this mission called Deep Impact. And Deep Impact visited a comet called Temple 1. It blasted a huge chunk off of it and found quite a lot. So let's visit Temple 1 and take that away and put in the official name here. And Temple, there we go. Take a visit to that. Go a little faster than usual here. There we go. There is Temple 1. Isn't it cute? Well, while we're here, let's actually land on this thing. See what that looks like to land on a comet. Whoa. Where'd you go, buddy? There we go. Oh my gosh, I think we're inside of it. I'm not a very good pilot here. All right, let's do this. Okay. There we go. That looks kind of cool. Yeah. Cool. That looks neat. All right, well, first off, what did this Deep Impact mission find? Well, it found that this thing had a lot of holes in it. Now, parts were very fragile and other parts were very compact, but apparently the ice on the comet acted as a glue for these chunks of dust and debris to stick together. Now, not only was there a fine layer of dust that was as fine as talcum powder, but there's also a lot of this black gunk, which was like this carbon-based kind of like this stuff that you would find on your barbecue grill. There's little black gunk that kind of accumulates on your barbecue grill. It's kind of like that. There's also layers to a comet which had gathered over time and over all of its orbiting of the sun. It kind of picks up this stuff. Now, there's also an abundance of carbon dioxide ice, which vaporizes much faster than water ice. So what is the deal with comets having two tails? What's going on with that? Again, we have this here. Yeah, just a little bit later on. There we go. So most comets have two tails. Now the tails appear as the comet approaches the sun. That's why the comets that we've been seeing here don't... Well, some of them have very faint tails, but these tails become apparent whenever the comet approaches the sun. So the sunlight pushes on things, but very gently, because the comet has these dust particles and they're very small. They are pushed away from the sun into this long tail. Now another tail is formed right here, this bluish tail. This is made of electrically charged molecules of gas and they're called ions. Now, very rarely a comet has a third tail, which is not visible to the naked eye, but it's made of sodium. And usually we don't see that with the unaided eye. We'll have to use instruments to see that. But that's why comets have these two tails. And one of it is dust and particles being blown off by the sun. And then the second one is this electrically charged particles, these ions getting blown off of the comet as it approaches. So another question we get asked a lot is, did the comets create our oceans? Many times there has been this hypothesis that Earth got water delivered to us in the form of comets striking the Earth back when it was first being formed. Well, scientists believe that comets may have in fact contributed some of the water for our oceans, or some of the molecules from which life eventually evolved. Some believe it may have been a comet hitting Earth that caused the dinosaurs to become extinct as well. Now, earlier on, I mentioned how Halley's comet was the origin of such meteor showers as the Orionids and the Eta Aquarids. Now, you may be surprised to know that comets are why we have meteor showers. So no, a shooting star is not really a star flying across the sky. It's actually debris left behind by a comet. So here is how that works. So a meteor is a space rock, or a meteoroid, right? It enters Earth's atmosphere, and as the space rock falls towards Earth, the resistance or the drag of the air on the rock makes it extremely hot. In fact, there's not enough time for the air to move away from the meteor traveling through the atmosphere, so it gets heated up. Now, what we see is a shooting star. The bright streak is not actually the rock, but rather the glowing hot air as the hot rock zips through the atmosphere. So when Earth encounters many meteoroids at once, we call it a meteor shower. Now, why would Earth encounter many meteoroids at once? Well, comets like Earth, there we go, and the other planets also orbit the sun. Now, unlike the nearly circular orbits of the planets, the orbits of comets are usually quite lopsided and oblong shaped. Now, as a comet gets closer to the sun, some of its icy surface boils off and it releases lots of particles of dust and rock and gas. So this comet debris gets strewn out along the comet's path. So especially in the inner solar system as it gets closer to the sun, where we live. Now, as the sun's heat boils off, more and more ice and debris get left behind in the path that this comet takes. So then, several times each year, as Earth makes its journey around the sun, its orbit crosses the orbit of that comet, which means Earth smacks into a bunch of comet debris that is still in motion around the sun. So there you have your meteor showers. Thank you, comets. Well, the other comet that I wanted to visit and mention is called hale-bopp. And that is not a Hansen song or a reference to a Hansen song. It is because it is tied to some wackiness that happened on Earth that was associated with hale-bopp that I want to mention, that I thought was, I guess, worth mentioning here. So this is a picture, an actual picture of hale-bopp. I'm going to actually go and visit it, though. So hale-bopp, found by two people, last name Hale, last name Bopp. Off to see hale-bopp. So first off, come on, why are you taking so long? I know you're out there, come on. There it is. God, it took forever. Let's get some motion going on here. Let's see hale-bopp spinning. All right, and you know what? Let's go ahead and land on it, because I thought that was kind of cool. So let's go ahead and land on hale-bopp. There we go. All right. I'm going to join hale-bopp here, as there we go. As if we were on the surface, zipping through the solar system. Okay, well, first off, hale-bopp made its appearance in 1997. And before that, its closest approach to Earth was 4,000 years before that. So it saw us during the Bronze Age, and then it saw us again during the Space Age, because in 1997 was the year that we landed Pathfinder on Mars. Now, you may also remember that hale-bopp was the center of this sort of weird belief of this UFO religious cult called Heaven's Gate. Now, they believed that there was this spacecraft following behind the tail of the comet of hale-bopp, and they attempted to rendezvous with this spacecraft whenever it was reached its closest orbit. Now, I don't remember seeing a spacecraft behind hale-bopp but I could be mistaken, so let me see here. I don't see a spaceship. No, there's no spaceship. Sorry. So, no, they were wrong about that, but they did give it the old college try, I guess. Now, by the way, interesting enough about that cult there. Now, this particular group was supposed to rendezvous with this mothership that was behind the hale-bopp comet. Before that, they actually purchased alien abduction insurance, which I did not know existed. Now, this insurance covered about 50 of the members and would pay out about $1 million in the case of abduction, impregnation, or death by aliens. Now, that being said, since the dissolution of the Heaven's Gate cult, actually there are about 2 or 3 more members that run the website, but anyways, after that, this company has stopped offering alien abduction insurance. So anyways, had no idea that that actually existed at some point, that you could actually buy alien abduction insurance. But that's going to be about it. I think it's around 7:30, so you've got about 30 more minutes before the sun sets. Let's go back to planet Earth here. And then I would advise to wait about... over here. Here we go. Wait about an hour after sunset. Around 9 o'clock or so. Find the Big Dipper. And then look low towards the horizon for a fuzzy star. If you have some binoculars or a camera that does long exposure, I would suggest a wide-angle lens first to first find its location, and then once you know where it's at, you can kind of zoom into that location, and then you will be able to sort of focus on that location and then take a long exposure photograph on that part. That is what I did. So, hope you enjoyed this show, all about comets here. Learned a little bit about Halley's Comet and some other comets. So join me next week where I will have a new show for you. Have a wonderful rest of your evening, and I will see you next week.